Welcome. Today we're going to talk about how we converted our TeamSpark ToolVault MCP gateway into a policy engine for a platform called Arcade.dev. So to start out with, let's review ToolVault a little bit. That's one of our TeamSpark projects. It's a local MCP gateway, so it's a self-hosted gateway you run on your local machine, and it handles all MCP client and MCP server management. So it does client discovery and rewriting, server management, supports MCP registry for server discovery and installation. So it's sort of a central place to manage all of your MCP clients and servers on your local machine. And it does a bunch of server security stuff too. It supports version pinning, automatic containerization, lifecycle management of locally running servers, a bunch of other stuff. But the real goal of that whole product was really just to have a place to have a policy engine. I really had a strong interest, and partially based on my background, in applying content policies to the traffic going between clients and MCP servers and then back to the clients. There's often not a human in the loop in that conversation. The humans often don't see all the details of what's going back and forth, and it can be some pretty sensitive stuff. So my whole goal was really to be able to build a policy engine I could deploy against MCP server, client and server traffic. And to do that, I built an MCP gateway. And the problem was the kind of people that thought it was a good idea to run a local MCP gateway and self-host it didn't particularly care about policy application and sort of vice versa. So that product never really found its market. But recently I discovered Arcade.dev, which is sort of what I had in mind in terms of the gateway, but done really right at an enterprise level. So they call it an MCP runtime layer. It's a lot more than a gateway. It is an awesome gateway. It has a ton of tools built in that are pre-configured. Their auth strategy is awesome. Like it's a very cool product. If you're doing something at a enterprise level, especially, it handles scale, secure. So sort of that part of it done right. So I got really excited about using that product just independently for other things. And then I noticed that they have this contextual access feature, which is essentially them being able to call webhooks before and after tool calls so that external products could evaluate that tool conversation. And that kind of gave me this idea, which is to essentially turn ToolVault into a policy engine specifically for Arcade.dev, where we can intercept the tool calls, we can inspect and modify it, apply our declarative policy language to all that traffic, and basically deliver the policy engine benefit that I wanted to deliver with ToolVault product, but to an audience that's using a scalable enterprise MCP product. So what we did was we cloned the repo and just ripped out all the MCP gateway code, which was probably 2/3 of the code in the product. So all the client discovery, server management, containerization, all that stuff is just completely gone. So it doesn't know anything about clients or servers or MCP really at all anymore. Because we're going to expose this new product, Pachinko, to the public internet so that we can call those webhooks and also potentially administer it from the public internet, we needed to make it multi-tenant and multi-user with authentication. So that was a little bit of a project to get that working, but that's now done. We also had to harden the API endpoints. So the API endpoints are all protected by a variety of auth mechanisms. You can either use the local client cookie if you're testing it in the browser, but generally you're going to use bearer token authentication, and we have full API key management now built in, so you can sort of manage and revoke API keys. And then lastly, we built the Arcade.dev webhooks. So we built the webhooks, we adapted the payloads that Arcade.dev provides, which are essentially MCP, but with a little bit of extra information in a few cases and slightly different way of doing things in a few cases. So we essentially we built those webhooks, and then we adapted the policy engine itself to work with those payloads, and we added a little bit of policy logic to deal with some of the things that Arcade.dev provides that MCP doesn't. So let's just jump into a quick demo. I'm not going to go into a ton of detail about this. There's a lot of information about ToolVault and how the policy engine works other places, and that part is pretty similar. So I'll do a quick run through. So when you come into TeamSpark, you can just npm install this and run it. The first time you run it, you'll set up your admin account through the web interface, and then you'll be able to log in, and you'll see an interface that looks sort of like this. This interface is populated with a bunch of sample data. So we have some scripts in the GitHub repo. If you want to play with those, you can to populate this with like 3 months worth of sample traffic to give you an idea of like how to interact with alerts and messages and things like that. So that's what I'm going to show you here. We are currently not hooked up to Arcade.dev yet. This is just a static instance with the preloaded data. So we have a dashboard that shows us policy alerts. We can see it's basically new alerts. Once alerts have been seen and marked, and they don't show up as new alerts anymore. So you can sort of keep track of when new things show up that you may need to deal with. We show them by level. You can see sort of policies, a little bit about the Arcade webhooks. And then you can see some charting with alerts and messages. So this is just sort of a high level, coming into the product to see what's going on. We'll go into the policies. So we can have a set of policies. They can be at different severity levels. They can be active or inactive. And I'll go into just the general idea. So we have, these are all pretty simple. They have very low false positive rates, and they're things that are pretty obvious to turn on. The idea is that individual users would figure out the things they cared about, and they would add more things to this. The policy engine is also extensible, so you can add your own types of conditions and actions if you want as well. But these are just things like cloud account secrets, general secrets, GitHub secrets, like PATs, LLM API keys, app tokens, credit card numbers, PII, internal network details, and UUID detection. And this is an example of something that you might want to just sort of flag, but you don't do anything about. You're not going to redact it. If you want to know if UUIDs are coming across, you can use that. And I'll just show you just a couple of these just to give you a general idea. Like, let's look at credit card numbers. So the way the policies work is they have a severity, they have an origin, which is whether it's client to server or server to client, or either way. You can filter on tools and toolkits if you want. Generally, we don't, but if you want to do that, you can. And then we have a series of conditions, and each of those conditions are named so that you can sort of have some information about which condition applied if there were more than one. So we have one for each type of credit card, and we have just a nice regex to match them. And then we have a Loon validator that does the checksum validation to prevent false positives. So this just identifies each type of credit card and tells you which type matched. And in this one, we're going to redact credit cards with this bracket star redaction pattern. So that one's pretty simple. And just as an example of another policy, I'll show you the PII one. Sort of similar, just a regex. So things like email addresses we can identify with regexes accurately. But something like social security number, it's very difficult to match those. It's just a series of 9 numbers that may or may not have dashes, and you're going to get a lot of false positives. So we also have a notion of keyword matching. You'll see this in like products like Presidio do a similar sort of thing. So essentially, like if the regex matches, then we look for one of these keywords within a certain distance before or after the match to determine whether to count it or not. So just seeing this pattern won't trigger this, but if like SSN or TIN or something like that appears around this, then it'll trigger that. So can be a little bit smart about contextual matching. You'll notice that when I go into these policies, I see the details of the policy, but I also see this alerts tab, and I can see, so there are 76 unseen alerts related to this particular policy. And if I wanted to go see what they were, I could go here. So there's a bunch of ways to get to this information and to drill into it, but that's just sort of one convenient way to do it. So let's go to alerts. So this is going to show us all of our policy alerts, and it'll focus on the new policy alerts up here. As you click on them, they'll get marked as seen, or you can mark all of them as seen or unseen manually if you want. So if we want to click on critical, it'll filter to critical or high. We can also click anywhere in these charts, and it'll sort of pivot. You can filter by these filter conditions. So I can filter by policies or by conditions. So if I wanted to see all the GitHub PATs, I can now see that, see what those all are. So just, I can change my time range. So just a general idea to have a little bit of a user interface to investigate what's going on. And then I can see the actual instances of policy application down here. We're going to dive into that quite yet. I also have all the messages. So this is all the message traffic. Again, I can sort of filter it by user, tool, toolkit. I can change my time range, have the same kind of charting I had before, and then I have a list of all the messages that came through. The general idea is you're not going to go kind of pawing through this. It's going to be more sorting and filtering if you're looking for specific things. The messages indicate whether the message triggered an alert. So that's an alert that would have shown up here under alerts. So let's go look at this particular one. So this is the user called dev, calling the fetch tool, and it generated an alert. So if we click on the message, now we can see the message details. So we can see it came from Arcade. The tool was fetch. The toolkit was fetch. Version number. This is the Arcade message ID. The user, when it's a real user from Arcade, it'll have a full email address, typically, or full user ID here. We can see this message originated at the client and the timestamp. And it generated a couple of alerts. So it generated an alert for GitHub secrets and one for credit card numbers. So we can go down here and see the params that were passed to the call, and then we can see the result that came back. So we can see, this is a mocked up one, obviously, but this is a fetch call that had a website that had an MX number and a GitHub PAT on it. So we don't want that to get back to the client, to the agent. So what actually happens is we can see this is the result sent by the server, and this was what we delivered to the client with actions applied. So we redacted both of these things. And if you want to get more details, if you click on this GitHub secrets, it'll highlight what it matched. So there's your GitHub secret. And then it'll also highlight the redaction. So you can sort of match up, oh, okay, this was in the original source and that's what it got redacted with. And if I go to credit card numbers, I can see like, okay, there was an Amex card right there and it got redacted to that. So that's generally how these work. Anytime you're looking at an alert, you're going to see the individual alerts and you'll see if there's more than one. You can click on them. It'll highlight what's going on in the message to sort of show you what it did. And sometimes there'll be more than one match, which you'll find. All right, let's jump into settings. The settings are very simple now that we've sort of ripped out all the clients and servers. It's basically just how you hook this up to Arcade. So we have the pre-hook and the post-hook. We have API keys. We don't have any set up right now. And then we have a couple of things around message retention and alert retention that you can set if you want. They default to 90 days. I'll come back to this in just a minute. We have Swagger docs for the API. So everything this app does is also available through API. You can use the same bearer token, same keys that we're going to use for Arcade to access these APIs from your own code to automate or do whatever you want with it. So basically everything that you can see that we did, we can do from here. If I want to just give an example, I can go to like list messages and run it, and you'll see that there's a big list of messages. So we can test all these APIs from right here from the app, and then also they're available as REST endpoints that you can auth to and use. And then we have a little bit of help, which is interesting, primarily in this case, because this quick start sort of walks you through when you're going to connect to Arcade.dev, sort of what you do. So you're going to generate a key for a bearer token key first, then you're going to connect to the Arcade engine and set the endpoints. And then you'll start reviewing the messages that get sent through, set up policies, triage and alert and monitor. So this is sort of the basic flow of connecting to Arcade.dev and then what you do after that. And then a little bit of a deep dive of kind of like more help into how each of the sections of the product works. So let's go back and let's connect this to Arcade. So the first thing is I'm running this on localhost. You might be running it on a local hosted machine or a machine on your network somewhere, or VPC, or who knows where. But generally, this server isn't going to know about its own externally accessible address, and it needs to have one. So in my case, where I'm running it on a local machine, I'm going to use ngrok to build a tunnel to get an externally accessible address. So I've already done that here. I just ran ngrok HTTP 3000, and it gave me a nice external routing to that. So let me copy that link address, and you'll see that I can actually also access, using that same external address, I can access the web interface. So that's sort of why we have authentication protecting this, because once you expose the webhook endpoints, you're also going to expose the web interface, but it'll be protected. So let's go back here. So as I said, generally a machine running a web server doesn't know its own external address. You have to tell it what it is. So here we're going to go into edit host, and we're going to paste in that ngrok external host. And now we have these pre and post hooks that have the full host, and these are actually going to be reachable from the public internet. So pretty straightforward. So let's go look at how we would actually connect this to Arcade. So we're going to go to Arcade, in the dashboard, we're going to go to contextual access, which is what they call it, and we're going to add an extension. We're going to call it Pachinko, and then we're going to turn on pre and post tool execution, and we're going to go back here. I'm going to copy this, and I'm going to stick it here. Okay, and now I'm going to copy this. And I'm going to stick it here. And then I need to do one more thing, which is we're going to need a bearer token key. So let's make a new key called Arcade. We're going to copy that. So you see now we have this Arcade key that's active. We can revoke it or delete it if we want. And then we're going to come in here and we're going to stick that right there. So we don't have to type anything. We're able to copy and paste the whole thing. And that's all you have to do. Just those two endpoints and the bearer token key. Now we've got this nice extension set up. So let's see. Yeah, let's just go to the playground and let's test this. This will be what's my GitHub ID? This will be the big test of whether we did this right. All right, that looks like it worked. So I asked it what my GitHub ID was, and it gave me my GitHub ID. And the only reason this will be cool is if, when we go back here, we see this message. So now we see a message that came from Arcade. He used the Who Am I tool from the GitHub toolkit. This is the actual version and the Arcade message ID and user and all that. So yeah, great, we got a message. So Arcade called us and ran this message through us before and after they called the tool. So far, so good. So let's just try one other thing. Let's go make a new policy. And we're going to call this Bob is Robert. We're going to match any tools. Let's add a condition. So we're going to add a regex that's going to look for Bob. And that's it. And then we're going to add, so we can either return an error or modify the message. So we're going to modify the message. And let's see if we can remove, redact. We're going to replace. And then we're going to replace it with Robert. And that should do it. Okay, so now we have this new policy called Bob is Robert. So let's go back to there and let's try this again. All right, sort of argued with me. It doesn't usually do that. So this is interesting. So now it says, hey, your username is Robert Dickinson and your name is Robert Dickinson, whereas up here it said Bob. So that seems like it worked. Let's go back and look at Pachinko and let's go to alerts. And then we see we have one new one here, which is called Bob is Robert. And let's look at that. So this is a message that I got where I got it from Arcade. This is the one I just sent. It was going to, the server returned my GitHub URL and login and name all with Bob. And what actually got sent back was Bob replaced with Robert. So we modified the content per the way the policy was set up. So that was kind of cool. And we got demonstrated that kind of round trip onto the Arcade dashboard where we had Bob here and we added the policy and now we have Robert. So that is basically the demo. This is available now. It's open source under an MIT license. The package is TeamSpark AI Pachinko. The repo is under TeamSpark AI Pachinko. You can literally just install it, run it, go to the web interface, set up it'll prompt you to go through setting up the initial account, and you can kind of follow the instructions I gave to integrate with Arcade and be up and going. So anyway, we're excited about it. If you have feedback, we're happy to hear about it. Let us know. Thanks.